Irodov problem 1.11 on the board. Two particles move in a uniform gravitational field with an acceleration g. At the initial moment, the particles were located at one point and moved with velocities v1 and v2 horizontally in opposite directions. Find the distance between the particles at the moment when their velocity vectors become mutually perpendicular. Okay, so for this problem, there are two particles. One is moving with velocity v1, the other one is moving with velocity v2. Okay, and they are under the influence of a uniform gravitational field. So what would happen is both would start to move downward. Okay, now the question is, at some point their velocity vectors will be such that they are perpendicular to each other. So let's say at this point, okay, so maybe I need to fix this trajectory a little bit. Okay, so their velocity vectors, after a while, they are perpendicular to each other. So this and this, if you extend, this is perpendicular. Okay, and they have reached these points. Okay, and it's given v1 is 3 meter per second and v2 is 4 meter per second. Okay, so let's say when they reach here, v1 is v1 dashed and this is v2 dashed. Okay, now what I'm thinking of doing this problem using vectors. So if two vectors are perpendicular to each other, then their dot product v1 dash dot v2 dashed should be 0, and that will give us a result. Okay, so but before that we need to find out what is v1 dashed and v2 dashed, and that is pretty simple. v1 we can write as, let's say this is the positive x coordinate and let's say downward is the positive y coordinate. So v1 we can write as 3 I cap and v2 we can write as minus 4 I cap. Okay. Now v1 dashed, so the component of v1 dashed in the x direction, it should remain the same because there is no acceleration in the x direction. So it will still be 3 meter per second. Okay. In the y direction, however, because there is acceleration in the downward direction, and let's say at time t they reach this point. So let's say this happens at time t. Okay, both these velocity vectors are perpendicular at time t. So what is the velocity that would have gained in time t under the influence of a uniform acceleration of g? It is plus gt, right? So plus we can write gt j cap. Okay. All right. One thing I want to do is, just to ensure we are dealing with the variables and we substitute these values later on, I will just write this as v1 I cap. Okay, the value of v1 I cap. Okay, v2 dashed similarly would be minus v2 I cap plus this component is still the same, gt j cap. Okay. Now we have V1 dash and V2 dash. So let's do the dot product. So V1 dash dot V2 dash we can write as V1 I cap plus GT J cap dot minus V2 I cap plus GT J cap. Dot products, we just multiply the i's, so minus V1 V2 and we multiply the j's plus g square t square. Okay, and this should be equal to 0 because that's the condition of two vectors being perpendicular. So that gives me g square t square is V1 V2, or we can write t square is V1 V2 by g square. Okay. Now let's suppose this coordinate is x1 y1 and this coordinate is x2 y2. Now we can clearly see y1 is equal to y2 because both cover the same distance in time t. So the distance between the two bodies at this condition is as simple as x2 minus x1 or x1 minus x2. Okay. Now how can we find x2? X2 is, or let's just do x1 minus x2 so that it comes out positive. Okay. Now what is x1? x1 is the distance that the body traveled in time t because of the x component of the velocity. So v1, or we can write v1 times t. Okay. And this one is minus x2 is minus v2 times t. So this becomes v1 plus v2 times t, and t is root v1 v2 by g. We could have simplified this. T is square root of v1 times v2 by g. Okay. Now let us substitute the values. So v1 is 3 plus 4 root 12 divided by, let's just do 10. So many meters. So 7 into 2 root 3 by 10, root 3 times 2 into 7 divided by 10. This is 2.4 meter. Okay. So that is our answer.